Hello, Hema Mukesh.
Yes, sir. We are waiting for the speaker now, sir.
Okay.
Sir will come by exactly 4 o'clock.
Yes. Okay.
Dear participants, welcome to this day 2, session 3. Please make a note of this email ID wiki@yahoo.com. If you have any queries after the completion of this session, you can text your questions and send through this email ID. Thank you so much.
I think sir.
Welcome, sir.
Yes, sir has come. I think so.
Yes, sir. Yes, sir.
Yes, you can start, na?
Yes, sir.
Shall we start, Hema Makesh?
Yes, sir. Yes, sir.
Thank you, thank you. Thank you.
Yeah, just 10 seconds. Yeah.
Please start.
Yes, sir. Yes, sir. Yes. Good evening, Professor.
Good evening,
Once
Professor
again, I welcome our expert, Dr. V.Shanmuganathan. Yesterday, sir has covered the topic called robot dynamics and part planning. Today, our expert is going to talk about robot vision and applications. I give warm welcome to our expert for this 1 week FDP. And also I welcome once again all our participants. Now I hand over the session to our expert. Thank you, Professor. Thank you.
Thank you, Professor Larasan.
Thank you, sir.
Thank you once again to Wayne Institute of Technology for inviting me, giving me this opportunity to
large number of participants. So I also thank all the participants for staying back late in the evening. So so today I'll have to manage with a medley of my PowerPoint slides here and there. So I apologize in advance for any possible disruptions. So before I go into the topic of robot vision, I want to continue some 2-3 slides of yesterday's path planning. So which I will do. We're discussing about path planning. So trajectory means is a path with a specific each point on the path will be reached at specific time. So you can have Cartesian trajectory where XYZ positions are functions of time. Not just Cartesian, not just that, even the pitch, yaw, and roll motions of the tool. That means the rotation about x-axis, rotation about y-axis, and rotation about z-axis of the tool. They are also important. So here this is a T for time. It looks like a cross symbol. It's T for time. Okay, so this needs to be found out. This is in the work area. Whereas, so Cartesian trajectory is the output, whereas joint trajectory is the input, because motors are connected to the joints. Because of the motion, rotation of the motors, you get the Cartesian motion. So in the case of a joint trajectory, each joint will have to be considered separately. Each joint will have to be considered separately. Suppose I have an industrial robot, there are 6 degrees of freedom, theta 1, theta 2, theta 3, theta 4, theta 5, theta 6. So I will have 6 different joint trajectories. The combined effect of all these joint trajectories is the Cartesian trajectory. Like you have a bullock cart with 2 bullocks, both of them should move as desired. If they move here and there differently, then the cart will not move correctly. So similarly, all these 6 joints should follow the pre-decided trajectory in order to ensure that the Cartesian trajectory is obtained. Cartesian trajectory is the actual task requirement because the tool moves in the Cartesian space, whereas the robot input to the robot is joint motions. Okay, so the joint trajectories are obtained through inverse kinematics. Direct kinematics means from joint trajectory to Cartesian trajectory. So joint trajectory to Cartesian trajectory. This is direct kinematics, whereas the Cartesian trajectory to joint trajectory is called inverse kinematics. So this is direct kinematics. This is direct kinematics. Direct kinematics means you move from joint trajectory to Cartesian trajectory, whereas inverse kinematics means you want to determine the joint trajectory to meet the requirements of the Cartesian trajectory. Cartesian trajectory is the user requirement. Okay, that is the user requirement. So joint trajectory, if you give, you can find out Cartesian trajectory. There is a one-on-one mapping. Only one solution is available. Whereas if you give a Cartesian trajectory, there are more than one options of joint trajectory is available. Like if you square a number 5, you take a square, 5 square is 25. Only one solution is there. Whereas if you take square root of 25, you have plus or minus 5. Similarly, why this occurs? Because, for example, joints means most of the joints are angular joints or a combination of angular and linear joints. Therefore, angles are involved. If you consider cos theta will give you only one solution, whereas cos inverse will result in 2, because cos of plus or minus theta is equal to the same value. So because of that, you'll have multiple solutions for joint trajectory. Which one of them will be decided? That can be decided by the algorithm. Which one? That depends on other constraints or user constraints or obstacle present in the path, etc. That will decide which of the joint trajectory will be used. Now, given a joint trajectory, you have to do path planning, joint trajectory planning. Okay, so 6 joints are there, I told you. So these I have shown only 2 links. Sometimes for simplicity, people in the textbooks especially, they consider only in the textbooks, they will consider only one link, one joint only. They will consider only they consider only one joint to explain the concept of joint trajectory. So very often you will discuss, you will hear people talking about one link manipulator, etc. Okay, so we have 6 joints in the industrial robot. So for each joint, you have to do path planning separately. Procedure is the same, depending upon what is the starting position of the joint, what is the end position of the joint, what is the starting velocity, what is the end velocity, what is the starting acceleration, what is the end acceleration. So based on these constraints, the joint trajectory is planned. So joint trajectory, how does it plotted? Time will be on the horizontal axis. Joint coordinate, theta 1, theta 2, theta 3, theta 4, theta 5, theta 6 will be plotted on the vertical axis. Intermediate points on the path are called via points or waypoints. Via points or waypoints. Okay, it's a very via point or waypoints. Okay, in Italian language, via means street or road. Okay, so via means way or path. Okay, points on the path are called via points. Via points may be sometimes the requirement. Okay, so for example, if you want to travel from let's say one city to another by avoiding a check post, then the path will be different. Okay, in such case you have to give via point. Then motion goes from the start point to end point through the via points. Okay, in the start point velocity is 0, end point also velocity is 0, because you are always starting from 0 velocity and ending at 0 velocity. Whereas on the via points, the tool will not stop, tool will keep on moving. Via points will have constraints or boundary conditions to be met, like what should be the velocity at the via point, what should be the position of the via point, what should be the acceleration of these data should be given by the task requirements. For example, if I do welding, and welding, there will be a starting point of welding and end point of welding. So there is a weld path. So the weld path, so sometimes it may be a very complicated path. In that case, intermediate points are given, and at each point, the welding rod will not stop. Okay, so this is a typical joint trajectory, which may look like this. So at time t equal to 0, you start at this one, and you may be ending at here. And these are all via points. So when I talk of point, it can mean Cartesian point x, y, z, as well as pitch angle, yaw angle, and the three orientations, three orientations of the tool. And if you do inverse kinematics, then you can find out the corresponding theta 1 or theta 2. For every point in the Cartesian space, there will be a corresponding joint angle. Okay, so now this is for just one joint. Like that, there are 6 joints in the robot. In the case of a snake robot, you will have as many plots like this for as many plots for as many joints. Okay, for one joint, you have one graph like this, and this graph shows the position only. Now differentiate it, you will get velocity theta dot. Differentiate once again, you will get angular acceleration theta double dot of the particular joint. So this has to be done simultaneously for all 6 joints. Okay, so there are something like pseudo via points. The via point, pseudo via point. Via points are actually on the path. Pseudo via points are like control points. Okay, so in computer graphics, they call it as via points, pseudo via point. They are not on the path, but they may decide the path. Okay, they may slightly deflect the path at local points. Okay, so okay, with this I stop the previous discussion. Otherwise, path planning requires a little bit of 1 more hour session, so I won't be able to continue. But you can refer to the books mentioned. Okay, so please follow it. And I am advised that we will not have question answer session today for want of time. You are always welcome to type your questions or queries and comments in the question answer section or chat section. Okay, so now I come to today's topic. Today's topic is robot vision. Okay, first of all, vision is the one. So vision, that's all. So vision, humans have vision. So human eyes are like a camera. Human eyes are like a camera. So vision means camera. And what do you get from a camera? You're using your cell phone, you take a picture. So the picture is called an image. So you get an image. Okay. Now, so basically robot vision requires image processing. Okay, robot vision means application of image processing for robot applications. That's all. That is the definition of robot vision. And people use three terminology. One is called machine vision. The other one is called robot vision. And the third one is called computer vision. These are the three things. For example, nowadays fingerprint sensors are very common. Fingerprint sensors are very common. So biometric. So even Aadhaar is based on fingerprint. Aadhaar is also based on iris recognition. In Bangalore, in one college, they are using iris recognition system for attendance of faculty and staff. Okay, iris, human eye. Every human has a different fingerprint, unique. Okay. Similarly, every human being has a unique iris. Okay, unique eye shape, unique eye geometry, unique geometry of the eye. Iris. Iris is the black colored circular portion of the eye is called iris. IRIS. So for everybody, for no two persons will have the same iris. So iris recognition can be used for biometric, and Aadhaar has already collected iris as well as all the 10 fingerprints. Now, once you have the fingerprint, how does Aadhaar recognizes? Actually, image processing is done actually. Once we give our thumb impression, so on the fingerprint sensor, that converts our fingerprints into an image, and so the thumb impression will consist of curved lines, and these curved lines, from the curved line, specific features are extracted, and that is used for recognition. Similarly, in our eyes, iris, so features of the iris are taken. Okay, in more complicated personal recognition systems, even the shape of the whole eye can be used for recognition. Okay, so as I told you, there is machine vision, robot vision, and computer vision. What's the difference between the three? If you use vision for a machine, you call it machine vision. If you use vision and image processing for a robot, you call it robot vision. If you use vision only for computational applications, you call it computer vision. Okay. Robot vision is also called by a name, visual servoing. What is visual servoing? When, let's say, when you play tennis, when two persons are playing tennis, okay, or somebody is bowling, another person is batting in cricket. Okay, so now now the batsman's action, think of batsman as a robot. The action of the batsman or the next motion of the batsman depends on the ball position, how it's thrown. So in other words, the action or reaction of the batsman is decided by the visual inputs. So the batsman responds to the visual inputs. The batsman obeys visual inputs. So it's called visual servoing. All of us do visual servoing. Okay, you are driving very fast on the road. All of a sudden, a cat or dog crosses the road. You apply sudden brake. So you are actually doing visual servoing. So industrial robots are just machines. They are dumb. They don't have any intelligence like CNC machines. But if you provide additional sensors like vision, then they can become more intelligent. They need not be programmed for everything. Right now, every single step of an industrial robot needs to be programmed. Whereas visual servoing cannot be programmed because you don't know what is the next move. If you don't know, if the programmer does not know what is the next move, it cannot be programmed. Nobody knows the next move. Okay, so visual servoing is very important. Driverless car is another example of visual servoing. So I will start by my presentation. My first slide, I would like to, I don't want people to simply listen some colorful pictures and then go away. I want you or your students to actually implement some of the image processing or robot vision tasks. So what software you can use? I will recommend OpenCV. OpenCV is called Open Computer Vision. You can download it from opencv.org. It was developed by Intel. I'm sorry. OpenCV was developed by Intel Corporation, and they have made it publicly available. So you can download OpenCV. And OpenCV is just a library. Okay, when you write some program, computer program, you don't calculate sine theta and cos theta. You simply mention sine 90, then you get the values. So similarly, OpenCV is a computer vision library for computer vision applications. Okay, next one, there is a mistake here. So okay, so you can also use OpenCV using Python also. Okay, Python is much simpler than C language. Then there are two other software. MATLAB is obviously known to many people, and Scilab is a free version of Scilab is a free software. So I would recommend all of you to use Scilab, because MATLAB you have to spend 10 lakhs, 20 lakhs, or if you want institute version, you have to spend 10 lakhs, 12 lakhs every year, let's say. Whereas Scilab is free. Most of the functionalities of MATLAB is available from the Scilab software. Scilab is a free software, totally free. Okay. Whereas MATLAB, they make either you have to pirate, or there will be limited feature demo version will be available for a small time. Or if your university or college has the MATLAB software, only during the working time you can use it. So once you go home, you cannot use MATLAB, or you may not be able to use MATLAB from your laptop. So in such cases, you can. I would urge all of you to download Scilab. In fact, IIT Bombay is the nodal center for popularizing the Scilab software. If you visit IIT Bombay websites, or if you Google for Scilab IIT Bombay, you will get a lot of information and help available. Scilab can also be used for computer control, automatic control applications. Scilab also has some robotics toolbox, or some of you can develop some applications for Scilab. So when you download Scilab is the basic computation. You have to download additionally the image processing module that may be available from the Scilab website itself. So these are the things I recommend. Now, I was in the beginning of my lectures, I was mentioning three terminology: computer vision. And computer vision can be divided into three types. Computer vision used for computational applications. Then robot vision is used for robotic applications. And machine vision. What is machine vision? If you use image processing for some industrial applications, that is called machine vision. Okay, so if you use computer vision for computational applications such as fingerprint recognition, that's computer vision. If you use computer vision for visual servoing for robots, then you call it robot vision. Okay, that's the difference. Now there are three things. What are the components of a vision system? Obviously, you need a camera. Is camera alone sufficient? No. You need a good lighting system. So you need a lighting system, you need a camera. Are these two sufficient? No. You need a computer that will do the image processing. So a vision system consists of three things. One is the vision sensor or camera, then the lighting systems, and the third one is the software that will do image processing. And image processing also, you have low level vision, medium level vision, high level vision. Low level vision will do mathematical algorithms for image processing. Then next one, once you've done basic image processing, then you have to extract features. What are the features? Maybe straight line, circle, these are all the features. And the third one is pattern recognition. Okay. For example, how will you recognize that an object is a square or a rectangle? It requires some intelligent algorithms. So that is high level vision. So pattern recognition comes there. How will you distinguish between a parabola and hyperbola? Again, this is pattern recognition. Okay. So how will you distinguish for a driverless car, yellow line and white line? Okay. How will driverless car recognize different tracks? How will a driverless car distinguish between a Maruti car and an auto? So these are all pattern recognition. So very often we may use natural lighting available. Okay. So, but then for machine vision applications, illumination is important. Special lightings are used for machine vision applications. Okay. So sometimes some special filters are also used. So illumination is very important. Okay. And different light sources may be used. Monochromatic light, white light. White light is natural light. Sodium vapor is monochromatic light. For some special applications, people are using ultraviolet. For example, you want to study the plant growth monitoring in a greenhouse. For agricultural universities may like to study the growth of plants under controlled conditions. So what is the effect of ultraviolet in sun? So if they want to study, then they may use some special lighting techniques. Or you want to detect fake currency note, then you have to use ultraviolet. Infrared is useful. Infrared is called night vision eye. Night vision. So obviously in the night there is no vision, but infrared is widely used by many animals and birds. Snakes use infrared. Okay, snakes use infrared. And there are some other insects. Some other insects also may use infrared. So laser is also used. Laser is used especially for accurate estimation of distances for driverless car applications, as well as industrial robots. I told you, industrial robots travel at very high speed. When the industrial robots travel at very high speed, the location of obstacles in the shop floor or location of obstacles in the path of the robot must be found out well in advance so that the robot can stop or choose some other path. So for that, people use LIDAR, L-I-D-A-R, LIDAR. LIDAR sensors were once upon a time very costly, but now cheap LIDAR sensors are available in the market. Even for a few thousand rupees or a few hundred rupees, you can get a LIDAR sensor. Similarly, another one is ultrasonic sensors. Bats, some insects like bats, they use ultrasonic sensing. Okay, they use it effectively. So for machine vision, you need a good light source, you need a camera, and you need also special lighting techniques. So it can be special lighting technique. When I mean special lighting techniques, special lighting we have seen. We also need filters. For example, when we drive or on hot sun, we wear cooling glass, sunglasses. So sunglasses actually, some cheap sunglasses you may get for 100 rupees, 200 rupees. That's just a toy that's useful for children. Those sunglasses only filter. They may not. They only filter ultraviolet light. So sunlight has ultraviolet. So if you buy a sunglass for 100 rupees, 200 rupees, it will block out maybe ultraviolet light. Ultraviolet rays will be blocked, but glare will not be blocked. So if you want to remove glare when you see, then you should go for costly sunglasses. They have a polarized coating. So suppose, especially when you are driving in the night, no glare will be there because of headlights of the other vehicles. So glare will be reduced at least to some extent. Also, when you drive in very hot sun, especially in city traffic or even the highway, you are following another vehicle within, say, 100 meters or 10 meter to 100 meters distance. If you are following another vehicle, so in a hot sun, that sunlight will be reflected from the windshield of the previous vehicle to the driver. So if you want to prevent that, then you can wear polarized glass. It will not be prevented completely, but at least glare will be eliminated to the maximum possible extent. Okay, so this is a requirement of machine vision system and robot vision. So whether it is machine vision or whether it is machine vision or robot vision, some certain things we have to. What do you want to see? Okay, so, and what is the capability of the vision system? Vision system means it may be a camera plus filter plus software. Okay, so you may see so many things. Okay, you may want to see so many things, but what do you actually need to see? Okay, what do you actually need to see? For example, Mahatma Gandhi had 3 monkeys. One of the monkey closes its eyes. Okay, so what do you want to see? Whether it is really essential to see that, whether it's essential for me to see the movie. Okay, so it may not. If it's not a requirement, then it should not be seen. Because no need, because the moment you see too many things, then you are loading the vision system software, then computation will take more time. And what is the what should be the what do you want to see as the user, or what do you want the robot to see? And for the robot to see, what is the requirement for the vision system? Okay, and how do you emphasize the scene? What do you mean by emphasize? If you use special lighting techniques, you are emphasizing it. For example, I want people to read, people to follow specific bullet point in my slide. Therefore, what do? I use a marker. Okay, I use a marker, then people are attracted towards that particular point. Okay, so what you want to see is only this point, not everything. So that is this. Similarly, you can emphasize. Okay, we will see some example how you can emphasize a particular part. For example, we have traffic signals. Traffic signal, why are they in different colors? Red, blue, and red, green, and amber. Red, green, and orange. Why are they there? Because then only it is possible to emphasize. Okay, so then where are the are they stable, and what are the components of the machine vision system? What kind of light sources can be used? What are the advantages and disadvantages? There are different illumination techniques. Different types of lighting can be used. Of course, we use natural lighting. We have tube lights, we have LED lights today, we have tube lights also, we have flashlights of camera, and we also have old 60 watts bulb with tungsten filament lamps are also there. So tungsten filament lamps, there will be a lot of shadow. Okay, you can also have laser beams. Okay, so different types of lightings are available. So what are the different types of lights? So here in this example, the same object is the same. What is that object? It's a glass plate with a chamfer. The glass plate with a chamfer appears differently in different types of lighting conditions. This is where those questions, what do you want to see? What do you need to see? Okay, what do you prefer to see? What do you need to see? That means what is the vision require? What is the requirement? Okay, what do you prefer? What do you require? And what is the requirement for the image processing software? So, and how do you emphasize? So by using different lighting conditions, we can emphasize certain features. Okay. Sometimes chamfer may be an important feature to find out. If I want to find out the chamfer angle or round radius, then chamfer is a feature. If I just want to know what is the size of the glass plate, then chamfer is no issue. Chamfer is not important if you are just if the robot is going to pick up the object. Okay, so different types of lighting conditions: diffuse, incident, bright field lighting, telecentric lighting. You look at this. If you use telecentric lighting, all the scratches on the glass is visible. So if I am, after all, if I want to go do pick and place operation, why should I bother about the scratches? Okay. So now directed incident dark field lighting, then transmitted light, transmitted bright field lighting, telecentric. So different lighting conditions, lighting can be used by using different light sources. So that is the reason why tube lights have limited shadow. This is another example. It's a potentiometer. Actually, the outer body is actually blue in color. Okay, so it's actually blue in color. It's blue in color. Now the question is, what do you want to see? Whether you want to see the screw here or whether you want to see the outer body. If it's a pick and place operation, then you want to see the outer body of the potentiometer. Okay, these potentiometers are used in radio sets. Okay, olden days radio sets. They use this potentiometer. So they basically, their potentiometers are nothing but variable resistors. So now the resistance value can be changed by changing the screw position. Now, if you have an automatic robot which is going to adjust the screw position, then the screw position must be seen. If it is going to do pick and place operation, outer body must be seen. So by using different color light, I will be able to hide it. Blue potentiometer under blue light looks yellow. Outer body is blue. If you use blue color, it will look bright in blue light. Now you can ask whether it is looking blue, but it is a gray level image. So either a monochrome camera used, or after taking the color picture, we convert it to a gray image. I don't use the word black and white. Okay, in the colloquial term we call black and white photo studio. No, it is actually gray level. Okay, level of gray or shades of gray. Okay. So it will appear very bright if the light is blue. If I use some other color like yellow, which is completely opposite blue, then any object that was originally blue will look dark. Okay, the objects which are not blue, they will appear. Or if the screw was yellow and I am using yellow light, only the screw is highlighted. That means I am using emphasizing. Once it is emphasized, the advantage is, for industrial vision applications, industrial image processing applications, I don't want to use very large software. For me, the job must be done with the minimum possible amount of time. Okay, therefore, there is no point in going for excellent software. I want a software which is very small, which can do the job in the shortest possible time. Okay, so then there's another application where we have a cap. We have I think cap of maybe used in an engine or some other component, some cap. Now each cap may be given different serial number or part number. Let's say there is going to be a character recognition system which is going to recognize the part. Therefore, these numbers must be read. So in the original picture, when diffuse lighting was used, these numbers are not highlighted. When directed lighting is used, those numbers are highlighted. Therefore, for image processing, it becomes easier. Okay. There's another, it's a same bolt under different conditions. This is the light spectrum. Okay, we will be able to see VIS. VIS means visual range. Visual range for the human. VGR range. Okay, we can see only this range. Okay, but there is also ultraviolet range, and ultraviolet is also as per German standards or Indian standards or American standards. It's divided into ultraviolet A, B, and C. Okay, so as you know, our human skin produces vitamin D, produces vitamin D from sunlight. Okay, and sunlight contains UVA, UVB, UVC. I forgot only one of the either A or B is good for human beings. The remaining two are bad for human being. If you are exposed to B and C, you will get skin cancer. If you expose yourself to A, then you are producing vitamin D. Okay, B and C will not contribute to vitamin D. So maybe morning time, 9 to 10:30, you may get good source of vitamin, good source of A ultraviolet. During midday, then B or C will be predominant. So I'm not sure which one is good for human skin, but only one of them. Okay, you can Google to find out. Then comes the infrared. Infrared also is divided into some. I think German standards divides it into infrared A, B, and C, whereas some other standard defines near infrared, middle infrared, and far infrared. Sometimes if you look for some papers, they will talk of NIR. NIR means near infrared. NIR camera. NIR camera means near infrared. What is near infrared? Its wavelength is close to the human, close to the red that human can see. Far means it is far away in the spectrum from the VGR range. Sorry. Yeah, this is German standards. DIN is German standards. Okay, this is not required. And this is a spectral response of different vision sensors. Okay. This one, long dashed line, it's a human eye during the daytime. Human eye is sensitive. This is the VGR range, 450 to 690 is the VGR range. So human beings are sensitive. Then what is spectral response? Certain amount of energy is falling. How much energy is coming out? How much energy is recognized? So human being has maximum sensitivity in the middle of VGR range. Middle of VGR range is nothing but green. That's why we all love green. We all love green because sensitivity of the human eye is maximum in the VGR range. Okay, that is one point. Okay, but if I want to buy a cow, I don't like a cow which is black in color. I would like to buy a cow which is white in color. White in color or slightly yellowish brown in color. But if I want to buy a horse, I'll be happy with black horse, or I'll be happy with white horse rather than a brown horse. Okay, so I'm talking about the physical sensitivity of the human eye, that is maximum in the green. Of course, there are social aspects. Okay, Indians are racist. We always want the bridegroom to be of a certain skin color. All Fair and Lovely, all these things. They are only projecting to make our skin fairer in color, light in color. So if anybody comes with the cream which will make you dark in color, nobody will buy. So there are social issues related to which color is preferred for which object. So that's a different issue altogether. So whereas if you consider the cameras, artificial cameras, and these are all different sensors. For example, silicon is a photosensitive material. Silicon has a sensitivity, it's WIPGR. If you look at this, where is red? Red is high wavelength. Red is high wavelength. Violet is short wavelength. So this is red. Okay. This range is infrared. Silicon, pure silicon, is photosensitive, and it has got less sensitivity in the WIPGR region, but very good sensitivity in the infrared region. There are also different sensors are used based on different material. Your CCD Sony camera had used a sensor, and this is this sensitivity. CMOS camera of this company has this kind of sensitivity. So different material will have different sensitivity. So, and sunlight has a peak somewhere in the violet and ultraviolet range. So that is why, if you take your camera and so if you switch on the TV remote, show the TV remote, switch on the TV remote in front of the cell phone camera, you can see it glowing. Whereas when we switch on in our eyes, we cannot see. Okay, because this silicon and artificial vision sensors, artificial camera sensors have good sensitivity to infrared. So most of the CCTV cameras for monitoring, they can recognize motion. They can recognize movements in the night also, because the artificial sensors are capable of recognizing infrared. So that's why the surveillance cameras also have infrared LEDs to illuminate in the night. Okay, so this is the luminous intensity. Okay, so that is some introduction about. We have only 8 minutes more, so I should wind up quickly. Just hold on. In the meantime, you can post your questions. Okay, so far I don't see any questions. So just 1 minute, I'll attend the call. Yeah, thank you. Now, what kind of technology can be used? What kind of technology is used? Which one you are seeing in the screen? Hello?
Image processing using MATLAB.
Thank you. So image processing can be done using Scilab and MATLAB, and I'll quickly show some examples of output. What you can do. You can read an image, you can display image, you can convert a gray image to color, and there is something called image enhancement. Human beings, our brain does a lot of image enhancement. What is that image enhancement? So for that, histogram is used. This is an example of image enhancement. This is the original picture. I told you it's a gray level picture. Shades of gray. You can give a numerical value of 0 to black, and maybe 2 power 8. 2 power 8 means 255 minus 1. 255 plus 1. So 2 power, if I use an n-bit register to store each pixel value. So our cell phone cameras now come with 20 megapixel, right? Pixel means picture element, each dot in the image. An image is basically a matrix, m by n matrix. Okay, m by n indicates the number of the pixels, image matrix size. When I say 20 megapixel camera, m multiplied by n is equal to 20 mega, to 20 into 10 power 6. Okay, that is called m by n. M means along the x-axis, number of pixels along the horizontal axis. N means number of pixels along the vertical axis. So now each pixel has a gray level value varying from 0 to maximum value. Let's say in this case, if I use an 8-bit register to store, then 250, then I plot this. This is called frequency level histogram. Okay, number of pixels that have a gray level of 100, number of pixels that have a gray level of certain value. So if you look at this, number of pixels having a gray level below 75 is 0. No point is having a gray level less than 70, and nothing has a gray level more than 175. Okay, so because of that, this image quality is poor. Now what we can do is we can do image enhancement. If we enhance the image, like so like normalization. Okay, normalization, if you do, then that's called image enhancement. You can have a better picture. Okay, compare this picture and this picture. So this picture is suitable for further image processing applications or image recognition. For example, the picture on the coat is very much clear. The eyes of the child is very much clear. Okay, so here the eyes of the child is not clear. Okay, so even the logo is not clear. So here the logo is looking much better. This kind of, there is something called binary image. Binary image will have only 2 gray levels: perfectly black or perfectly white, nothing in between. So you can also do image arithmetic, you can add images, you can multiply images, all those things you can do, image rotations, etc. You can also use image processing using C languages. I will quickly show to something else. This is Fanuc. Some robot manufacturers also have Fanuc have a camera for machine vision applications. Okay, so I just want to, I will conclude. I'm now concluding with a few slides on stereo vision. Stereo vision is very important today, especially for visual surveying applications and driverless vehicles, driverless cars we are talking about today. So stereo vision and LiDAR sensors are important. What is stereo vision? Human beings have 2 eyes, so that is called stereo vision. So conventional, if you use single camera or single eye, you can only recognize X direction and Y direction, but the depth or distance, that is Z axis, cannot be seen. So only if you recognize both X, Y and Z, you will be able to find the 3-dimensional value or the distance of the object. That's why 2 cameras will be required. Kinet camera is one example of 2 camera systems. So that is called stereo vision. So using stereo vision, we can do a lot of things. For example, if you use stereo vision, the left side camera and right side camera, same scene will appear at different locations. So by finding out the coordinates of the corners of the rectangle in these 2 cameras, we can recognize what is the depth also. Okay, so this is image processing. So I think with this I will conclude. I have maybe if you give 1 minute, I will just show one case study. I guess I have got it. I don't know whether I got it. Okay. Yeah. So one of my student worked on. Two of my students right now are working on image processing based applications. I thought I will share the case studies. So I have 2 minutes. I think within 2 minutes, at least 2 or 3 case studies I'll quickly show. I will show only the output. I will not discuss the algorithm. There is not much time. So one student is working on face recognition. He's just doing it a hobby, 3rd-year mechanical engineering student. Face recognition uses Python as a platform and uses Raspberry Pi and OpenCV. Okay, so this is just a board design of the Raspberry Pi is available, and so this is for face recognition. This is a setup. This is Raspberry Pi. Are you able to see my Professor Elilarasan can confirm?
Yes, sir. Yes, sir. I can able to see.
So this is Raspberry Pi is basically a small computer. Okay, even our cell phones are computer, but Raspberry Pi is a small computer. You can even connect a screen, you can connect USB cable, all those things. And this is the student who is working on it. And face recognition. If you look at this, the algorithm has recognized at least it has recognized the boundary of the face. This is one thing. Is one application. There is another student. He is working on his final year project for agricultural image processing, and this is the actual project that we are working on. I have not informed the student that I am going to discuss this in a public seminar, but I'll quickly show. Where is that? Okay. Yeah, I'm just, yes, you got it. So I'm showing it from my WhatsApp actually. So here we are using for agricultural image processing. The task given was recognize the fruits, and there are different types of fruits. And so we are using deep, what do they call it? Deep learning or artificial intelligence. So artificial intelligence, we are using some artificial intelligence algorithms to recognize different types of fruits. So mainly recognize the boundary shape and compare the different sizes, and then you have to train the algorithm. So that is one thing. And we also got some more outputs, like how will you recognize a apple? Then so apple from the leaves needs to be recognized. Okay, so there is an apple. So apple is recognized. Two different apples are recognized by the bounding rectangle. Okay, so for that pick and place operation, I can control a robot to go and pick and now I know the coordinates of the rectangle. The robot knows how much, where to go, how much to open the gripper, etc. Right. So we've been successful to that extent. Many other people have already done it, a lot of things. So this is doing the project with mechanical engineering students is really a challenging task. There is one more. Professor Lilarasan, will you give me some 1 minute time?
Yes, sir. Yes, sir. Yes, sir.
I will show the third case study. I'm not going to take much time because there is one area called optical flow. That's very important. Optical flow. In the previous two examples, face recognition, the object will not be moving. Can be moving, but it can be stationary. Human head can be kept stationary. The other example, apples, oranges, the fruits can be kept stationary. In some applications, the fruit is moving along the conveyor, then the object is not stationary. Therefore, the bounding rectangle also will be moving. So this is called a visual servoing problem, even when the object is moving. So driverless car also bounding rectangle. In that case, you have to use what is called optical flow. Optical flow means the corner points have a velocity. Okay, so optical flow is another interesting area. Yes, I guess I can quickly locate that one slide. One slide I'll be able to quickly locate. Okay, so I've got that. I will just show. And here is an example of optical flow. That moving object recognition using vision camera is that's very important. I think I will play the video. I guess I had static slides also. I will play the video. And after this video is just short video, a few seconds only. Yeah, so do you see video display on my screen?
Yes, sir. Yes, sir. We are seeing.
Yes. So here we want to recognize a moving object. Okay. This video will run hardly for looks like it will run for 2 minutes. So this is the robot. We had a small robot in the lab, and somebody was asking whether there is an Indian robot. This is an educational robot from MTAP. So of course it can be used for pick and place applications. But we wanted to give some visual input to this robot. Okay, so how we do it? Sorry, it's a wrong video. Okay, this is the yeah. So I will just show just 2 slides. I'll show and stop. So this is visual surveying. I think you are able to see visual surveying on the screen.
Yes, sir. We are seeing, sir.
Okay.
Yes, sir.
So this was a project done by a student for a competition. That student is now doing PhD in Simtech, Singapore Institute of Technology. So here, depending upon the object on the green arena, the robot will choose its path. Okay, it will either go to this place or it will go near the object. So depending upon whether blue object or yellow object is thrown on the arena. Okay, so that is one. And this is object tracking. So this is the robot I had shown, and we use the battery as the object. We assumed that if an object like this is moving along the conveyor, then camera will recognize it. So once camera recognizes it, the information should go to the robot controller, and robot controller will decide its motion based on the motion of the object. So here we have done the image processing and using optical flow technique. And so these are locations of the battery from the top view, from the overhead camera at different locations. So that gives us the coordinate reference point of the object. If you can see in each of these pictures, the location of the object is slightly different. Okay, and there is something called gesture sensing. Gestures, Kinect camera is available along with the Xbox. Many of your children may be having Kinect camera. Kinect camera has stereo vision, 2 cameras, and it is also having an infrared camera and it also has microphone, using microphone array. Using the combination of all of these, it will be able to do recognize the motion recognition or gesture recognition. Gesture has an important role in human communication. Middle finger means something, little finger means something, index finger, if you show, it means something, and if you wave like this, it means something. People who are have hearing disability, and they use sign language to communicate. So if you use a camera like this, it will be possible to recognize the gestures. So these are some of the applications of robot vision. There is not much time to discuss the algorithm, which may go for hours together, but I'm very happy that I've been able to share part of my knowledge on robot vision with you. In fact, I started my career in robot vision after my BTech, although I'm a mechanical BTech mechanical engineer, but I was interested in robotics. So at PhD College of Technology, I was able to join as research fellow after my BTech, and started working in robot vision. So robot vision was my first task. So before knowing about kinematics and dynamics, I had started learning robot vision. So I'm happy that I'm able to do at least some, even in not in great institutes of the country. So I'm able to guide some student project in this area. So thank you very much, WEMO Institute of Technology, Professor Elilarasan and Professor Rao, for having given me this opportunity. And indeed, it's a pleasure interacting with such a large number of participants. I see 144 participants are right now there. So there is not much time. So somebody has written, as the participants are teacher, if the session started with these applications of face recognition, fruit identification, moving object recognition, etc., then the session could have been more attractive. Okay, sorry for that. So maybe I'll take this feedback in future sessions. In fact, there was also much less time for me to prepare. So thank you. So otherwise done. So thank you. So I think most of you know my contact details, or you can contact the organizers of the FTP. Thank you.
Thank you, Professor. Now I request our participants, if anything wants to ask any queries, they can share their question in the question and answer icon.
Sir, ask them to send email, sir. I'll conclude.
Okay.
Maybe we can take one questions, one questions like a pickle.
Yes, sir. Yes. Okay.
Yes, sir. We have one question here.
Somebody has posted a question. Can we use robotic emotion system for analyzing the student behavior at the classroom or at home? The emotion recognition is indeed one area of research actually. What is emotion after all? So lip movement, you recognize the lip movement, that is emotion recognition, whether somebody is sad, somebody is, forget about the classroom in general. Two things. One is whether somebody is sad or smiling or laughing. So that is that's one thing. And to find out whether the guy is actually listening to you, whether your boss is actually interested in telling what you tell him. So that requires a little bit of research. But emotion recognition, like simple emotions like laughing, smile, already research, good amount of work has been done. Thank you. Good question.
Thank you, dear participants. If people have further any queries, we will send you the email ID. To that email ID you can send your queries. Now, thank you, Professor, for your wonderful presentation on both the topics titled Robot Dynamics and Part Planning and Robot Vision and Applications. Now, and on behalf of our WEMO Institute of Technology and our participants, I thank you for your presentation and the immediate consent you are given to give talk on these various topics. Really, we all have got updated our knowledge related to the robotic field, all because of you only, Professor. Thank you very much once again. Thank you.
Thank you very much.
Thank you, my dear participants. You will shortly get the another You will shortly get the link for another session for tomorrow. Thank you, and all. Thank you.
Thank you. Thank you very much. See you, Professor Elilarasan and Professor Rao.
Thank you, sir.
Thank you.
Bye, sir. Bye, sir. Thank you.
Am I, sir, end the session, sir?
Yes, sir. Yes, sir. Dear participants, please make a note of this email ID. If you have any queries, you can write on. Okay, you can write your questions to your this email ID, wikisana@yahoo.com. Thank you so much for your active participation. Thank you. We will meet again by the next session by tomorrow. Thank you.